Hello, welcome. Guys, we are getting to some really fun stuff. I love this section. Inscribed angles. I can find the measure of inscribed angles. So I think what I love about this is it's not like it's hard. It's just like a puzzle. But sometimes you're like, why can't I figure this out? And all of a sudden you're just going to see it out of nowhere. And it's like, wow, that was easy. And I figured it out. We're getting to some really fun stuff, like my favorite stuff. So I'm just excited, and I'm excited to share it with you. So let's talk about inscribed angles. Okay, again, lots of information on this first slide here. So let's just talk about what an inscribed angle is. An inscribed angle is an angle with its vertex on the circle with two sides that are chords. So if we look at our angle here, we have our center that's on our circle, and its sides are made up of chords. So here's a chord, and here's a chord. So angle ABC would be considered an inscribed angle. Okay, so that's exciting. The next piece here, an intercepted arc is the arc that lies between the endpoints of your inscribed angle. So you guys see how I have my endpoint here and here? Our intercepted arc would be AC because it's between the two endpoints of our inscribed angle. Now, probably the most important piece of this whole little chunk of information is that the degree of the inscribed angle is equal to half the measure of its intercepted arc. So let's pretend here, folks, let's pretend that this arc was 100 degrees. I know that angle B over here would be half that amount. Oh no. Always. So half of 100 is 50. So make sure you get this down for me. Measure angle ABC is half the measure of arc AC. All right. A few other things to talk about here. Intersecting a diameter. So, if an inscribed angle intercepts a diameter, then it is a right angle. So let's break it down. Here's our diameter, right? It's a chord that goes through the center. And we have an inscribed angle BAC here, right? You guys see how our endpoints are the endpoints of that diameter? Well, then we would know that angle A there, or angle BAC, is 90. Why is that? Why does that make sense? Okay, well, think about it. A diameter cuts your circle in half, right? So if there's 360 degrees and I'm cutting it in half, I get 180, right? So this arc here is 180 degrees, and we just learned that your inscribed angle is half its intercepted arc, so half of 180 we do know is 90. So that's why that is true. So measure angle BAC is 90 degrees. And the last thing that we need to kind of discuss before we get into some examples is overlapping arcs. So if we have two inscribed angles that intercept the same arc, then those angles are congruent. And this is kind of like another duh. So if we look here, folks, we trace out our inscribed angles of angle ABD, right? Do you guys see that inscribed angle? And then I trace out our inscribed angle of ACD. Do you guys see and agree that they both have the same intercepted arc of AD? Yeah, they both have the endpoints A and D, duh. So that being said, we would know that these two angles formed would be congruent because they have the same intercepted arc. Woo! All right, let's get to the fun. Find the given measure. We are looking for the measure of angle WXY, we are looking for this angle right here. Okay, what's our process, folks? Come on, tell me. Well, we would know it's half the measure of our intercepted arc, so 62 divided by 2 is 31. So 31 degrees. Can we go the other way? This time we're looking for the measure of our DGF. So this is what we're looking for, DGF. And we know that our inscribed angle is 113. So 113 times 2 gives us 226. 226. We doubled it. All right. We are now looking for the measure of angle PQR. PQR. Well, what the heck? We don't have anything. We don't have an arc measure or an angle measure. So, not possible. We're done. Well, remember, folks, I told you I'm never going to give you a problem that was not figure-outable. You got to be smart. You got to be a thinker here, right? And be observant. So please observe, folks, that this is a diameter, right? 2 endpoints on the circle, and it goes through the center. So we know that this arc over here is 180. And we know that 180 divided by 2 gives us 90. 90 degrees. This is a right angle. And we're done. Next. Oh boy, a lot going on this one. Let's check her out. Okay, let's see here. We are looking for the measure of angle RST. Okay, let's trace it out. R to S to T. Again, I don't know what the measure of arc, like what is this? What's RT? I don't know, but can I figure it out? You can figure it out. So if you notice, folks, again, this is just a puzzle. It's a game. It's work your picture in your favor, right? Look, we know that this is 64 degrees, this is 139 degrees, and this is another 75, right? So we're almost all the way around our circle. So in order to find the missing piece, we simply what? Subtract from 360. Yes, so 360 minus 75 minus 139 minus 64 should give us a total of 82. So we just found that our RT is 82, but now we have to answer the question. That wasn't the question we were trying to figure out. What we're trying to figure out is what's the angle of RST. So RST would be half that, right? So 82 divided by 2 is 41. 41 degrees. That was cool. Good work. Kind of fun, right? Kind of fun. And now we're looking for the measure of angle RUT. So from R to U to T. Hey, look at that. It's the same arc, right? So again, 82 divided by 2 gives us 41. They have the same intercepted arc, which means that they are equal. All right, next. Inscribed quadrilaterals. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, please don't forget, supplementary means they add to 180. That is something you will never, should ever forget from coming from geometry class. But okay, so let's review a quick few things. Quadrilateral means it's a shape that has 4 sides, or polygon. So here's our 4-sided polygon, A, B, C, D. And they're telling us if this happens, it's inscribed in a circle, then our opposite angles here are supplementary. So angle A plus angle C equals 180, like angle D and angle B. They also are supplementary. So let's try a few examples of these. Find the given measures. So we are looking for the measure of angle J and K. Let's just start with J. So can we agree, folks, that we have a quadrilateral here inscribed in our circle? So now we know that opposite angles are supplementary. So J is opposite angle L, so now it's a really easy problem. 180 minus 92 gives us 88. Wow, 88. All right, angle K is opposite angle M, so same story. 180 minus 45 gives us 135. And now we're done. Moving on to our last example for this video lesson, folks. Find the value of x. Okay, so let's see here. We have a quadrilateral, right? So we know that opposite angles are supplementary. So I know that J and H are going to add to 180. However, we don't know what H is. Okay, so you got to think, how are we going to figure this out? Well, again, I hope you're being observant and you're kind of making some connections here. If we trace out our inscribed angle of GHI, and we look here, we have our intercepted arc, right? So our intercepted arc, 96 plus 50, gives us 146. So that big blue arc's 146. And we know that our inscribed angle is half of that. So 73. So we just found that this angle is 73. And now we have a pretty easy problem, right? Because angle J and H are supplementary. So now we can write 12x minus 25 plus 73 is equal to 180. So if we combine like terms over here, 73 minus 25 gives us 48. Subtract over our 48, we should get 132. Divide out, folks, we should get 11. Pretty wild. I don't know. I love this stuff. I like how it's just kind of a puzzle, and sometimes you see it and sometimes it takes you a second to figure it out, but it's not like it's super hard. Okay, I'm off my soapbox. Thanks for watching, kids. We'll see you in class. Adios, adios, adios.